Hello, this is question 5 from the Spec A MAT paper from 2009 when they released this. So we've got songs from the Martian classical period had just two notes, X and Y, constructed according to rigorous rules. The sequence consisting of no notes was a song. Okay. A sequence starting with X followed by two repetitions of an existing song and then ending in Y is also a song. Okay, a sequence of notes obtained by interchanging X's and Y's is also a song. Okay, all songs are constructed using those rules. Right, so we start with a period of silence. Anyway, we make things longer is by bracketing an X at the start and a Y at the end. And then we can swap around X's and Y's. Right, okay, and then when we go up to the next one, we have to do double the song. Okay, right, fair enough. Write down 4 songs of length 6. That is songs with exactly 6 notes. Okay, so if we're going to do this, so we have to start with our blank song, which means we can then go to X with 2 blanks and then a Y. So we've got that, and we could also flip that for a YX. So there are our 2 length ones. So if we wanted to then go to length, oh, we're going to go straight to length 6, aren't we? Because we have to put 2 of those. So we could have X, X, Y, X, Y, Y. So that would be one option. We could go X, Y, X, Y, X, Y. That would be another option. And then we could flip all of those and say Y, Y, X, Y, X, X. And Y, X, Y, X, Y, X. So that's 4 songs of length 6. So that's probably all of them, actually. I can't think of any other way we could make one. So anyway, that's those. Part 2. Show that if there are K songs of length M, then there are 2 K songs of length 2M plus 2. Right, so well, as we go up each time, we're 2 K songs of length M. There are 2 K songs of length 2M plus 2. So when we're going up in length, we're bracketing double the song, aren't we? We're doubling up a song, we're bracketing it with an X and a Y. So that's how we're getting to 2M plus 2. So for each of the K songs, can duplicate and bracket with XY, i.e. that is rule 2. Rule 2. That leads to K songs of length 2M plus 2. And then we can flip them all. We can flip, then use rule 3 for K new songs, which leads to 2K songs of length 2M plus 2. Because then you can't flip anything beforehand. If you flip something, if you did a rule 3 before you did a rule 2, it's just giving you the same set of songs. Because if you've got the complete set of songs of length M, doing rule 3 isn't going to help you. It's not going to create anything new. So we don't have to worry about anything going in the other order. Right, so that's done that bit. Is that all apart? So, oh no, we go. Deduce that for each natural number there are 2 to the n songs of length 2 to the n plus 1 minus 2. Okay, so let's go blue. Let's get our song lengths. Allowable song lengths are going to be, so we're going to go 0, then we're going to go 2, then we're going to go 6, then we're going to go 14. Okay, so these are all 2 less than the power of 2. So that's what's going on there. So this is, am I going to put these into a sensible order? So I'm going 0, 2, then what am I doing? I'm doubling that and adding 2. So 2 squared plus 2. Then I'm going to be doubling that and adding 2. So 2 cubed plus 2 squared plus 2. So that's my sequence of lengths. So it's just a geometric sequence then, isn't it? So that is the length n is going to be equal to, first term is 2 to the n minus 1 over 2 minus 1. So that is 2 to the n plus 1 minus 2. Okay, so I've got the length bit. And then each time we double the number of songs. So, and each increase in length, i.e. n to n plus 1, doubles the number of songs. And we've got for, so each natural number, there are 2 to the n songs. Yeah, for 0, we're getting, for n equals 0, we get 1 song. Okay, so does that actually come out as, yeah, for L is 0, I'm getting 2 to the 1 minus 2, so that is 0. So I'm getting 2 to the n songs. Okay, yeah, that's fine. So that's done that bit. Let's get a new sheet up. Songs of the Martian later period were constructed also using the rule: if a song ended in Y, then the sequence of notes obtained by omitting that Y was also a song. You can leave off a Y at the end. Okay, what lengths do songs of the later period have? That is, for which natural numbers n is there a song with exactly n notes? So we can take a Y off at the end, but we can flip Y's and X's whenever we want. So surely we can get any length that we want. So, okay, so if the last note is Y, then remove it. Actually, I should start off with something before this, shouldn't I? Let's start off by saying, using rule, where are we going? Rule 2, I suppose, aren't we? Rule 2, there is no maximum length song. Okay, so that's the first thing, because now we're going to be going back down from a maximum. So with using rule 4, this is our new thing, if last note is Y, then remove it to get a song of 1 length shorter. Get song of 1 shorter length. If last note is X, then use rule 3 and then rule 4 to get a song of 1 shorter length. 1 shorter length. Therefore, all length songs possible. All length songs possible. Okay, so that was another fairly easy question in this. I might as well do question 6 as well, seeing as I'm here, and that wasn't a very long video. So here we go. So let's bring up this one. So we're back to Alice, Bob and Charlie, who they don't tend to use in these papers anymore, but they certainly used them a lot back in the day. Now, well-known expert logicians. The king places a hat on each of their heads. Each of the logicians can see each other's hats, but not his or her own. The king says each of your hats is either black or white. You don't have all the same colour hat. All four are honest. They all trust each other. King now asks Alice, do you know what colour your hat is? Alice says, yes, it's white. What colour are the other hats? Right, so if they've got to, you've got to have some hats of each colour. She knows hers is white, so the other two must be black. So what colour are the other hats? They're black. They don't ask for any explanation on that one, which is interesting. But still, that would be the explanation if they asked for it. She knows it's white. It must be because she can't see a white one, and there has to be a white one. So part 2, the king now changes some of the hats and again says, each of your hats is either black or white. You don't all have the same colour. He now asks Alice, do you know what colour your hat is? Alice replies, no. Can Bob work out what colour his hat is? Right, so explain your answer. Right, so if Alice says no, therefore Bob and Charlie must have different colour hats. So therefore Bob says that, well, he knows that he's got a different colour to Charlie. So Bob says opposite of what, therefore Bob says opposite of what he sees on Charlie. Of Charlie. Okay, so that's fine. Part 3, the king now changes some of the hats. He then says, each of your hats is either black or white. At least one of you has a white hat. At least one of you has a white hat, right? So he hasn't said anything about black hats. He now asks them all, do you know what colour your hat is? They all simultaneously reply no. So what can you deduce about the colour of their hats? Explain your answer. Right, so there can't be 2 black hats there, can there? Because otherwise someone would say, well, I can see 2 black hats, so I must have a white one. So here we can't have 2 black hats. So what can we do? That'd be it then, wouldn't it? Therefore, we've got all white or 2 white, 1 black. Okay, explain your answer. So that was that one. Well, there's another bit on this. He asks again, do you know what colour your hat is? All right, so he hasn't changed things around. He's just asked again. Alice says no, but Bob and Charlie both say yes. What colour are their hats? Right, so we got a difference here between Alice, Bob and Charlie. So we had the initial, look on the right sheet, initial options were white, 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 or white, white, black. Well, it can't be white, white, white. So Alice now different, so it can't be white, white, white. So must be white, white, black, with Alice wearing black. Which fits, because if she's wearing black and she sees 2 whites, she still doesn't know if she's got a white hat or a black hat. Whereas the other 2, if they're standing there both looking at Alice wearing black and then there's a white hat, how does that work? So yeah, if they were looking at Alice wearing black and them and the other person wearing white, then they would know if they were wearing black, someone would have said on the previous question that they must be wearing white. So yeah, that fits. But you've got a symmetry thing here. You can't have 3 of them wearing white and one of them behaving differently to the other 2. So it has to end up being that way. Right, that was an epically quick one of those. I think even when they were doing the actual Alice, Bob and Charlie questions, they weren't quite as quick as that one. So yeah, again, it's fitting with a trend on this paper. I would do question 7, but I actually haven't copied it in here yet. So I'll have to come back and do that in the next video.